Okay, so for this week, we're going to talk about dictionaries. And no, we're not talking about the book in the library that you guys don't want to go reference, right? Dictionaries is another data type, just like lists, all right? So like a list, a dictionary is a mutable collection of values. However, unlike lists, we have indexes, right? So anybody remember what the indexes are for lists? What does it start at? 0, right? And it'll work its way up depending on how many values you have. In a dictionary, we don't use indexes, we use what's called keys. And keys are the same thing, only they have some value to us. So there would be something like a string that says first name, a string that says last name, something like that, versus index 0, index 1, etc. Okay. And these are known as key value pairs. So we have a key and we have a value as it comes out. So if we look at this dictionary on the screen, you have my cat, and then you have the squiggly brackets. All right. So square brackets are the ones that are lists. Squiggly brackets, right, or braces, whatever you want to call them, are used for dictionaries, right? You set it up the exact same way you would a list, only instead of a value here, right, we would have something like whatever. We have a string, colon, and then a string, right? This allows us to specify what the key is. So we're going to have a key of size, a value of fat, a key of color, and a value of gray, a key of disposition, and a value of loud. Does everybody get that? So if I want all the keys out of here, I would get size, color, and disposition. And if I wanted to specifically pull the size out, I would say my cat size, and I would get back the value, which is fat. All right. The benefit of this is I don't have to remember that I stored the size of my cat as the first index in my list. Right. If I was using a list, I have to know index numbers, where in a dictionary, I just need to know the name of the key that I want to pull out, or the value. That way I can get the value that returns back out of it. All right. Because we are using those, and you can still use integers for this key if you want to. Like here, we're using strings, right? You can use an integer like, say, 42 if you wanted to, but you don't have to. And you can use this as an integer if you wanted to. It doesn't matter. Okay. So because lists do not have a fixed order of indexes, they are considered unordered, which means there's no order or direction to what's inside of a list or inside of a dictionary. All right. So inside a dictionary, if I was to print this dictionary out, it may have size first, it may have color first, it may have disposition first. It doesn't matter. There's no order to a dictionary. All right. Anybody got any questions on that? All righty. So if I had a list here, and I'm saying list this time, a list of spam equals cats, dogs, moose. I have bacon equals dogs, moose, cats. Note that if I compare these two, AKA is spam equal to bacon, that's going to come back as false, right? Because this is index 0, this is index 0. Those two are not the same. These are not the same lists. Even though they have the same values in them, they're not the same list. Does everybody get that? That's with lists. If I do that with dictionaries, that's going to come back as true because there is no order inside of there. Anybody got any questions on that one? Okay. Which means we can also not slice a list or slice a dictionary, right? There's no way to do that because there's no order. We can't say from the first value to the third value, give us back those results. Can't do that on a dictionary. There's no order to it. So we can't use slicing in there, right? If we ask for a key that doesn't exist, so say we have this dictionary where a name is Zophie and an age is 7. If we ask for the key of color, we're going to get back a key error, meaning that there is no key named color. Everybody see how that works? Pretty straightforward. All right. If you did that in a list, you would get what kind of error? If we asked for index number 4 and it didn't exist, we would get a index error, right? Okay. So we can do a couple different things with dictionaries. Let me see what we got here. Just fire up our idle. Everything squared away here. And let me get this down to the bottom. Okay. So if we want a dictionary, we can call it something like student one, right? And we've got a dictionary, and the first key we want to have is something like first name. And then we want to give it a value, and we're going to say Sam. All right. Now, does first name work there? Yeah, it's fine, right? It's a string. We can do whatever we want. All right. I can also have a key that is, say, 42. It's a number, and that 42 equals or has a value of hobo. I don't know. Coming up with random stuff today. All right. And we can have the opposite of that. We can have a string that says age, and my age is 32. Okay. So notice I put these down in the same order that we did as a list, where I have a key value pair as it goes down all the way here. I could stretch that off on the screen. It'd be hard to read, so make sure you keep it nice and uniform. Anybody got any questions on this one? So if I want to get back the name, I would say student one, and I would ask for the first name. And this would return me back Sam. So if I printed this and then run this little script here, we can see we get Sam back, right? If I want to add things to this list, I just need to specify them, right? So if we wanted to put Sam's last name in there, we would say student one. We would say his last name is equal to somebody give me a last name. Johnson. There we go. There we go. And now this dictionary overall would have this key value pair inside of it. So if I was to print this dictionary, student one, we can see when we run this out that the first time it repeats Sam. And then when we print the dictionary out, we have first name of Sam, 42 is hobo, age is 32, and last name is Johnson. Now it added it to the end of it, but there's really no order to it, right? We just added it in there. Everybody see how we added to a dictionary? You simply give the dictionary name, you give the key that you want to specify, and you give the value as whatever you have here for Johnson. Anybody have any questions on that? Now, say I had a list of students, or in this case, a dictionary of students, rather. And let's do something like first name. Actually, these are going to be better as attributes, right? So we have student one there. Let's do student two. And we're going to set up that dictionary, very similar to this first one. Instead of Sam, we'll do Chase. And let's just get rid of that one. Let's do something more like eyes are blue. And age is 17. Okay. Now, if I wanted to print student two, I would just print student two. If I wanted to print back his age, what would I use? Square bracket is age, right? Square bracket, close it off. So if we run this, what did I forget here? Oh, forgot my quote. There we go. So we printed this first one out. We printed student two. which came in here. Notice that it printed out the student 2, and then we got the age out there as well. Now we may have an overall list. I'm going to move this one up here next to student 1. We could have what is a list of students. So we would have students equals square bracket student 1, comma student 2. Right? This is a list of the students, but for each one of those students, we have a dictionary where we can store things like their first name. Let's change this to eyes. It's going to be red and 32. Okay. And so if we want to print our students, we're going to get a result that looks like this. Come on. Commas. Commas are important. You would see that we get back a list of dictionaries. Does everybody see how that works? So we have a list on the outside. The first thing in that list is this dictionary. And the second list, or second thing in that list, is this dictionary. Okay. If I have a dictionary and I want to get back all of the keys or all the different traits of this student 1, let's call them traits, right? We don't have to, but the idea here is that we are storing all the traits of student 1. So we set all these keys. To get all the keys back, we could use student1.keys. And if we print that, let me get rid of this print here on students. We get back what's called dict keys, and then what looks like a list, first name, eyes, and age. Okay. This student keys is going to return all the different keys that are available in that list. And that way we could then look up and say, okay, those are my keys. Now I wanted to print his age. I could go back and do student1.age, or I'm sorry, student1.age, like that. And it would go ahead and print that age back out to us, right? But note, this is a list-like object. It's not actually a list. It's called a dict keys object, and it's like a list, but not a list. If we want it to be a list so that we can actually do stuff with it, we have to convert it to a list. So to convert that to a list, we would say my keys equals list, and then we're going to call it student1.keys. Okay, we use what's called the list function to actually convert it over to a list, in which case if I print my keys, we can now see that I have a list of all the actual keys that are available. Okay, so dot keys is going to get us back all the keys. If we want to get back all the values that are on the available, we would use dot values. So if I want to get dot values, we're going to call this my values. And I would need to pass that into the list function as well to get that back. And we run this, you would see that we could get back all the values. Now, of course, we got to print my values. And we can see we get a list of Sam, Red, and 32. Notice that there's no order and there's no idea what key that's associated with, right? We have no clue. So if I say, give me back red, I don't know what key that's associated with. It just gives me a list of the values. So that brings us to the last one here, which is student1.items, right? And student1.items is going to give us back a tuple where the first one is the key and the second one is the value. So if I run this, you're going to see I get this dict items type, and it's a list of those. And of that first one is a tuple where the first part is the first name and the second part is my value, which is Sam. And then I have a tuple where the key is eyes and the value is red. This allows me to do a search through there, right? I could then get back what is what inside each tuple. Right? So what I could do is I could say Let's find out if last name is in this keys, right? So I would say if last name in student one dot keys, print student one last name. What that will do is print whatever the last name is if that key exists in that dictionary. Which if we run this, what's going to happen? It's going to crash. Why is it going to crash? Okay, let's run it. Well, it didn't crash. It just doesn't do anything, right? Because we have this in an if statement that's doing a check to see if this is true or false. And in this case, last name in student keys is false. Therefore, we don't execute the print and we go down to the end of the program. Right. So this is a way for us to check if a key exists inside of this dictionary. We could do the same thing with the values. We could see if Sam exists in there. And if Sam does exist, then we could print something, but we don't have a last name. So if I do something like this, now we're going to fail and we would get a key error, right? And that's not the same. Sam. Now we're going to get this key error because last name doesn't exist, right? Even though we found Sam up here in our values, this doesn't make any sense doing this because we know that list doesn't exist. All right. So you can check to see if something exists in the keys. You can check to see if something exists in the values. If you want to pull back your items, you would get tuples. Now, what's nice with the tuples is you can do a for loop inside of there. So for, let's say key comma value in student one dot items, we could say print the key is, and then we could print the key. And then we could have another print statement that would say the value is plus value. So what this is doing is, if you remember right, it gives us these tuples over here, right? We're assigning this first value that shows up here, or this first thing, to the word key, and we're assigning this to the value. Okay, we can use whatever we want here. We could use key value, we could use K comma V, we could use anything that makes sense to us. It doesn't matter what it is. All right. This is your multiple assignment trick. In other words, we're assigning the value of key to this first part and the value of value over to this part. All make sense? It's tricky when I keep using the words key and value inside of there. All right. The idea is we could run this and we can get a much cleaner output of the key is first name, the value is Sam. The key is eyes, the value is red. The key is age, I can't concatenate an integer. All right. So we would want to make sure that we stringify all of our values so that we don't run into an issue where an integer can't be printed out correctly. All right. This is easier and makes more sense than just printing this to the screen. So anytime you guys print a dictionary, you need to use a for loop with a multiple assignment trick in the items and print it out accordingly. All right. If you guys remember in lists, I asked you to always do a for loop through a list and you would print each item out nice and clean. All right. Anybody have any questions on lists so far? So we know how to set things in the list or in a dictionary. We know how to get back all the values. We know how to get all the keys, and we know how to get all the items. All right. So that covers all of these methods that we have available here. If you want to check to see if that key exists, we covered that. We can see if it's in. We can also use a not in, right? So if we wanted to see if it is in there or not in there, if last name not in student one dot keys, then we could go ahead and set it. We could say student one last name equals Johnson. Now it's going to do a check if last name exists in these keys, and if it does not, it will go ahead and set it into Johnson. Okay. If you want to get a value out of there, for example, we have something like last name, right? So if we say print student one dot, or I'm sorry, student one last name, we know that's going to fail because that key does not exist, right? We can use what's called the get method on this student one, and that's going to try to print that out. But if last name doesn't exist, it will return a default value to us. So we could say something like print, and we would say student one dot get. We want to get the last name. And if last name does not exist, return the string does not exist. Okay. We can close that up. And if we run this, that get method is going to go look for the last name key. It doesn't exist. So we respond with it doesn't exist. We can do whatever we want here if we wanted to. We could put in Johnson, right? And if we print our student one right after that, notice how it returned Johnson, but it never actually changed the dictionary. All it did was check to see if last name existed. If it did not, we're responding back with whatever we put in this second part. If it does exist, for example, if we went to first name and we run this, well, then it's going to go ahead and return first name of Sam. And you'll notice the dictionary never changed. If it doesn't exist in there and we want to set it, instead of .get, we're going to use the set default method. So here I would say set default. And in this case, I'm going to set this back to last name. And so now, if last name does not exist, I'm going to add it to the dictionary with whatever value I put here. So now I have first name of Sam, eyes, age, and last name with Johnson inside my dictionary. All right. So set default is going to basically do a check to see if it exists. If it doesn't, go ahead and set it. Anybody have any questions on that? Now notice when I tried to print this dictionary, it's a little ugly, right? Kind of runs off the screen, doesn't really look good. If you guys want to print out a dictionary just for the purposes of seeing what's in it, you can use a module called Pretty Print. So at the top, we're going to import pprint. And then down here, we would use ppprint, and then we're going to print out student one. And what that will do, if we run it over here, you'll notice it still didn't change anything, right? Well, the reason is because we don't really have a lot of items inside of here. So if we actually added some more items like height, 62. If we wanted to set their weight of 180, let's set their, I don't know, glasses to false. Shirt is red. And now if we try to print this out, of course, you got to put commas at the end of all these. You'll see that pretty print aligns everything nice and clean off on the left-hand side. Does that all make sense? So when is it going to actually do it? It's if it doesn't go beyond 80 characters. You guys remember how that runs off on the screen, right? So if I bring this back and keep this all in one big line, once I get past 80 characters, it would start organizing it for me correctly, right? We're going to keep it this way so it makes sense. So pretty print is your friend if you want to find out what's all in your dictionary and you want to print it out in a nice clean fashion so that you can see it going down, as opposed to it just printing out a blob like this. All right. However, in your homework assignments, in your midterm exams, etc., don't print like this. If I say show everything in your dictionary nice and cleanly, pretty print does not do it nice and cleanly, right? The correct way of doing that would be a for loop for key, comma, value in student one dot items. And then we would print it out accordingly, however we want. So say print print our key plus a colon space plus whatever the value is. We could do it this way. And we get some nice clean value there. So values, whoops, I had an S, value. There you go. Now, obviously, again, because we have integers, we need to stringify these. And it'll print it out in a nice, clean fashion. This is much cleaner output in the correct output versus actually setting the other one. All right. Anybody have any questions with dictionary so far? Yeah.
Anytime I do the 4 key value is 1, it doesn't.
If what now?
Anytime I do the 4 key comma value, that was those 2 lines, it just doesn't work. It just didn't get better.
What's the error?
It says print type error unsupported operand types for plus integer and string.
Yeah, that's because your value is integers, right? And so you'll need to stringify your values over here. You need this part here.
Oh, okay. Yeah.
Yep. Yeah, what it was trying to do was use print with these integers. And remember, when we do print, we always have to convert them to strings. All right. So we have the pretty print module. This is going to print things out nice and cleanly. As you can see, is it going down there? Let's see here. So why would we want to use dictionaries? Well, the main thing with dictionaries is that we have known keys versus 0, 1, 2, 3, 4, 5 for indexes, right? So it's a great way of storing information and it makes it more relevant to you. It's like having a mini database. All right. So for those of you that are coming from other languages, deal with databases, etc., having a dictionary is like a little mini database because you have a key value pair. All right. So a key value pair may work for something like, say, a chessboard, right? If we look at a chessboard, we have a coordinate system all the time, right? So A is this first column, 8 is this row going across. So if we say A8 and we have no value here, that means it's an empty space, right? If we look for our king, and that king is in what? H5 for the black one, right? And the C1 is in, or the white one is in C7, 6, yes. All right. So that allows us to build this coordinate system so that we could store information. So that's kind of like a tic-tac-toe game, right? So if we wanted to build a tic-tac-toe game, we would have something like board equals, and then we have a dictionary, and we have one called top left, so top L. And right now that is empty. So I'm just going to put some empty spaces in there. And we're going to build this out all the way across. So we could do something like top M is empty and top right is also empty, right? And then of course we can start this on down. Now, obviously this can be in one long list. We're just going to start this out so that it sorts correctly so that we can see it easily. So we would have something like mid L, and then we could change that. I'm just going to copy and paste so I can shorthand this. So now this is mid. This is mid. These need to be capitals. Like this. This is mid. Okay. If I can spell correctly. Mid. And then we're going to do our bottom row. Call it low. Okay. And this would represent a tic-tac-toe board. So right now, if we have nothing on the board, everything is empty spots going all the way across, right? We want X's or O's, and we could have actual spaces in there if we just put spaces in here. That way we can actually have something show up on the board. So something like that, right? And they call it the board, but that's fine. Doesn't matter. There we go. We can align this if we want. Something like that. The way we can see it. Okay. So that represents an empty board that looks like this. And if we wanted to print that, we could use a print function for that. So print the board, and we could go ahead and print that out. If we wanted X's here in the middle, then that would look like an X out here in the M, right? That would take this, and we would have an X. All right. So let's print that out here. We're going to scroll down and grab his function here for print board. And if we look at this function, we are just printing the top left, and then we're building a simple line in there, right? We're printing the pipe symbol. Scroll over here so we can see all this. I got this zoomed in here so you guys can see in the classroom. Then we print these individual spaces, the spaces. And so if we actually run this little bit of code, we get a nice little tic-tac-toe board. Okay, so how does this work? If we look at this first print line, it's grabbing whatever the value is here. Then it's concatenating it with the pipe symbol, grabbing this value, concatenating it with another pipe, and then this value, right? And then we just print out these lines. That's just printing out this line. And then we do the same thing for the top and bottom. So if we had a question, that would be something like print player one, pick a spot. Right, and then we need to get input from the user. So we're going to say move equals input in a spot. And so what we need to do is actually have something for them to know how to pick what spot is what, right? Because that doesn't really make sense. If they were just to print that out, we wouldn't really know how that worked, right? So if we come over here and we look at this code, we're going to grab another little piece down here. So we're going to start with X, because X always goes first, right? And we say for I in range of 9. Why would we say I in range of 9? Does anybody know why we say that? Only 9 possible moves, right? Let me get my formatting in here correctly. All right. So we're going to do a simple little loop for I in 9. We're not really using I. We're just wanting to make sure we go through this loop 9 times. We're going to print the board, this here. We're going to say turn for, and then whoever's turn it is. So turn for X, move on to which space. We're going to gather that input from the user. We're going to take whatever they type in and make that our turn. And if that turn is now equal to X or O, we put X or O up here in this spot. So let's just run this little app. course, my indentation's wrong. Why is it wrong? This all up. So what happens. Oh, here, print board. Okay, so we have this. What spot do we want to move on? And we would have to specifically type in top L in order for it to put an X up there, right? For O, if we wanted the bottom, we would use low dash R, right? If I type in gibberish, nothing happens. If I type that in multiple times, it just wastes the turn and goes on, right? That makes sense? Because it's not really doing a check to make sure that's a valid key. So how would we check to make sure whether or not that was a valid key? AKA whatever they're typing in, is that actually a spot on the board? Based on what you guys have learned today. Whoops, sorry, I forgot about the chat on here. White space on print board. Yep. So the board is this running board, and we're constantly changing this dictionary when somebody adds it. We should probably give them a moves board, right? And what a moves board is it tells them what those positions are. AKA, we're going to steal this, and we're going to give that this value here. We're going to steal this, and we're going to give this value here. And this gives them this value here, right? And then if we printed move board, moves board, same way, we just need to pass in the board and therefore print welcome to my tic-tac-toe game. Okay, then we are going to call print board and we're going to call the moves board. And if we run this program, you can see that we have welcome to my tic-tac-toe game, and we can see it starts to print it out. Now, the problem is I didn't finish it, but we'd have to put that in. Now, is this very easy? Right? So we could take this. We need to put this in here. I say easy, meaning that they would have to type in these spots like this. Let's copy these. All right, so now if we rerun this, we can see the board, but notice how these lines don't really match up anymore either, right? So what's another way of going about doing that?
Space stuff.
Well, we said there was how many turns? 9 turns, right? So if we have 9 turns, why don't we just use, why is there only 9 turns? Only 9 spaces. So fix what I did here. Put out the wrong thing. Make sure I get an empty board here real quick. There we go. All right, so if we just put 1 through 9 in here, 2, 3, 4, 5, 6, 7, 8. And if we run this, still didn't get that. What I do? Take out my print? I did. Print board moves board. There you go. So now we have the moves board that shows up there. Let's throw in a couple print underneath so that we get some space. We could say something like print. Here are the available spots. There you go. Something like that. So now as we go through here and check this, we have printing the board and we ask what move they want to check on. How could we, one, make sure they're giving us valid input for this move? So now we're wanting them to type in these available spaces, right? 1 through 9. How can we check they gave us a valid move?
Wow. If statement.
Some kind of if statement, right? What's that if statement going to look like?
If.
So if move. It would be moves.values, right?
Oh.
Moves board dot values. Then we can go ahead and continue on with it, right? So that would work, except we need to know what corresponds with what, right? So if they give us a 1, well, now our move is 1, but if we put the board 1 in there, it's not going to know what those are because the keys are top left, top middle, top right. The problem is we know the value and not the key, right? So we're telling them to put in all these different 1, 2, 3, 4, 5, 6, 7, 8, 9. But what we really need to know is top left, middle left, lower left, etc. So if you guys think about it, how could you check that? There's not a built-in Python function to do that. But if you guys wanted to write your own, how would you check that? Well, one, we would need to know the key and the value at the same time, right? So which one of those dictionary methods you guys learned today gives you the key and the value at the same time?
Item.
Items, right? So let's look at items. We could say for what? Key, comma, value in moves board dot items. That's going to give us back the key and it's going to get us back the value. So now what do we want to check? If our move is equal to what? The value. Now we know what the key is. So what would we do with that key? We would do this code, right? In which case we would take the key and make that instead of our move. Everybody see how that works? So we're going to first check to see if that move is in these values 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. Right? If it's in there, then we're going to do a for loop. And the first time we go through this for loop, we're going to get the key value out of this, saying the key is top left, the value is 1. If we typed in 1, does 1 match this value? If it does, then take this key and plug it into the board down here. So now if we run our program, and it says move on to which space, and I say 1, notice how it put an X up there. And if we say 9, my O went down on the other side, right? 5 gives us an X and goes through. Now, what if I wanted to win this game? I have to what? Get 3 in a row. So how am I going to get 3 in a row now? X would have to go in 2. O would have to go into what? 6. Which O was already in 6. Which doesn't make sense. It's because somebody doesn't add a little case of dyslexia here. 4, 5, 6. Let's try that again here. Okay, so they go in 1, O goes in 6. X goes in 2. O goes in 5. Yeah. And then 3, right? Well, there's nothing in the logic to tell it, hey, if those 3 in a row, you won, right? So how could we write that? We need to write the logic to check that. Let's create a function that would do that for us. What would that look like? I know this seems boring, but this is actually setting you up for your homework assignment. Because in the homework assignment for 3, you guys do nothing but write functions. So if you don't know how to write functions, this is testing that you know how to write functions. So we want to write a function that's going to check to make sure that there's not 3 in a row. So let's call this our game checker. Okay. And in this game checker, we're going to take in our board, right? And then what do we want to do? So this board is going to be the board, right? And how are we going to check if there's 3 of the same thing across here for these different rows? Everybody's getting starry-eyed. What do we got here? We got somebody online. You need to check the indexes for 3 directly next to each one other for 1. Yeah. But the problem is we don't have index numbers anymore, right? So we're going to have to hard code a little bit of this. So what is a possible win for our tic-tac-toe board? All the way across, right? So we would want to take these. And we could say if, and then we would check our board, right? So we would have board, square, this is equal to what? Has to be equal to X, right? In this case, we're using capital X's. And then we check the next one, board of top M is equal to X. And board, messing this all up here. Catch. Let's get this over here where I can see it. Okay. So board R is equal to X as well, right? That's one whole condition. If all those are X, what do we print? X wins, right?
Different ways, and then I'll do it all again for as well.
Let's start with that, right? So if board goes all the way through, what's the next one then? All the mid ones, right? So let's just copy this real quick. So this would now become mid. Then we're also going to print X wins. And then for the low, any other times it would win? Lots of different checks, right? So is there a way we could shorten that up a little bit? Anybody got any ideas? We're gonna just brute force it and hard code it, right? Well, there's some commonalities here. What are you guys determining? That this row is a pattern, right? Of some sort, right? So let's just do something like this. Pattern 1 equals what? Board top left, board top middle, and board top right. Something like that, right? That's pattern 1. If it's in those and all of those were X's, then it would win. X wins, right? What's another pattern? Just the same 3 that we did, right? So for the sake of this, we're just going to type out all of our patterns to make sure that we get them all. So we just copy this. And this is already saving us a little bit of typing. Mid, and mid. Because it also works in the reverse direction too, right? It doesn't really matter, right? As long as it's checking in one direction. So let's do pattern 3. All right, what were our other patterns that you guys said? So we got our 3 across. We need to know our vertical ones, right? So that would be pattern 4. You're still going to save some code, but right now there's not, right? Because there's so many different combinations. You got to at least tell the program what the combinations are. So what would this one look like? This one coming down, right? Top left, board left. See how I make use of copy and paste? Makes it less daunting, right?
Use. So do control C, control V, or do you? I forgot one just like right click on the mouse or something. For what you're doing to just copy and paste it real quick.
I'm just doing control C and control V. Yeah. Okay, so the next one would be all M's, right? And the point here is I want you guys to think of how you could do copy and paste so you're not hand coding every single one of these going through. So we go through 5. These are going to be R's. Oh, thank you. We have 5. We have 6. And what's our other patterns? Diagonals, right? So what would that look like? Let's steal one of these. Top left. Mid M. Lower right. What's our other diagonal look like? Top R. Lower left, right? And it doesn't matter which direction we do it because it's the same check, right? All we're checking is to see if all of these equal something. All right. So it took a little bit of hard coding, but now instead of having to write all these cases for X, right? And then we turn around and have to copy and paste that whole thing for O's to see if O wins. Now we can simply just say, if all these values are equal to whatever it is, then we can write it. So let's just write a little bit of code that does that. If, say we have pattern 1, right? And better yet, let's make this a little simple and do patterns equals a list of all of our patterns that we created, right? So pattern 1, pattern 2, pattern 3, pattern 4. What's that?
Pattern 7, pattern 7. Should be pattern 8.
Oh yeah, thank you. Pattern 8. There we go. 5 and pattern 6. And pattern 7 and pattern 8. Right? So what we did here is we created our individual patterns that have the pattern that we want. And then we made a list of all those patterns so that we can loop through it, right? That is so that I don't have to do if blah, blah, blah in pattern 1, if blah, blah, blah in pattern 2. Now I can just loop through the whole thing. I short-coded all of that by putting this all in a little list. Now I can do a for loop through that. So for pattern in patterns. Okay, so now it's going to take that first pattern, and what do we want to do? We want to check if all of them are X's. What would that look like? If pattern, what are we actually wanting to check though? If X in pattern, right? Meaning that we want to have an X in this going across. That's one way to check it. That's just going to get us back 1X though, right? So this check is just going to see if X is in there one time. That's not quite what we want. What are we wanting to do? If pattern 0 equals what? X. And pattern 1 equals X. Pattern 0 being the first one that came out of here, right? Because now we're using lists, so we have indexes. So that's index 0, index 1, and index 2. That makes sense? So we're checking to see if those are all X's, and if they're all X's, then X wins, right? What's our other option? Well, we probably want to check for O's too, right? So we would copy this whole line. And we would check for O's. That is not what I want to change there. Are O's. And I was using zeros. We actually want O. All right. And if that is true, then what? O wins. Anything else we got to check?
Oh, we need to, if it's a tie.
Right. That would be if basically all spots were filled, right? That makes sense? Because at the point that nobody has all these patterns, and we need to check that inside of our loop down here, right? So we do a turn. After we do a turn, first thing we need to do is run our board checker, right? Game checker. We're passing in the board. So that we can check to see if that is valid. All right. If we get down to the very last one, we need to say nobody wins, right? Essentially. So if I equals 9, print what do we say?
It's called the
Cat game, right? I was hoping somebody would know that. So cat game, meaning that nobody wins, right? Then we can end the program. Now we probably ought to end these programs if they win, right? for the time being, just a one-time through. So how could we end the program? Sys, yep. And after they win, we just tell them what? Sys.exit. Okay, let's play our game.
Could you make it a draw then for you? Three pieces of code and then it starts it again.
We could. We haven't got that far yet, but yes, that's what I want to do next. So we have all our available spots. We have a turn for X. We're going to move on to what? 1. Okay. The board failed. All right. So how did we fail? It's because I forgot that this is a capital B. Let's try that again. And you were sadistic for choosing spot 1 right off the bat. Tic-tac-toe. All right. Where are we putting O? Now notice it went straight down to O. So what happened when we ran this game checker? Notice I hit enter and immediately it pops up for O. What all happened when we hit that? Right? It hit this spot. It said turn. It put in an O. It came down here to game checker. And in game checker, it took this board and it had to check whether top L. It did every single one of these pattern checkers for both O and X like that. Right? So it looks like it's a lot of code and it looks like it's doing a lot of looping. But when it actually executes, these computers are fast. All right. So it's super, super fast. Even your watch will calculate that fast. All right. But we condensed it down a lot without having to write every single possible combination by just putting our possible wins. And then we put those in a pattern and start doing for loops. Just loop it through until it finds it. So now in our game, where's O going? 5, okay. 3. 2. Well, at least it checked now and it said that didn't win. So now who? 8. Now we blocked everybody, right? Now what? Let's try to see if we can get a win. We're going to block him? Yeah, we want to win here so we can see if our code works. 7. All right. 6. O wins. So you can see that even though it took us quite a bit to add this little game checker feature, it really didn't take long to play the game, right? So now let's do what you said. Let's play the game multiple times, or at least give them the option to play over again, right? So how would we do that? We could go that extreme, or we could just do a while true game here, right? We take all of this, and instead of exiting the game, we're going to return false. Or sorry, let's return true. Instead of exiting, we're going to return true. Okay. And this game checker, we can say if game checker, which just figures out whether or not we get true or false back. If it's true, then we're going to print, do you want to play another game? In which case we can have a little while true loop that will get an answer from them. And we could say something like, what? Choice equals input. Let's get an input from the user. And what would that, we need to have a little check on that. So if choice, what? Okay. then we would start them over, right? So let's do a check for, let's up here say yes or no. Okay. So when we do a check, we have a yes. And of course, we know people answer yes in capital Y, lowercase y, just the letter Y, right? So how can we shorthand that so we don't have to write out so many options? Let's do a little list that says yeses are equal to yes in all caps. It could be equal to yes in all lowercase. It could be equal to a capital yes. And we could have something like just a Y, right? Maybe a capital Y. Those are all our possible Y options that could go through there. And we could do the same thing for no's. No. No. In. Okay. So yes, this takes a little more coding, but if you think about it, it's a lot easier than writing out all your if statements, because then you got to copy code over and over and over. If it's in there, we can just say if choice in what? Then we would continue on. Let's write the case in which case we want to end the game. So if we would first just check for no's, right? If our choice is in no's, then we could print thanks for playing. Because we want to check for no's right off the bat. That way, if they're done, there ain't no sense in writing more code, right? So we have sys exit there. Elif choice in yeses. Then we do what? Just print something like starting the game over, right? Starting game over. In which case, what do we do now? We just break, right? We're just breaking out of that whole thing. And this whole check here that we're doing is inside of this. And while no, notice how this is getting a little complicated. We should probably write a function that just does this whole end part so that it ends and returns and out of there. For now, we're just going to leave it in here. The idea is I want you guys to see how building a tic-tac-toe game is, right? So this would be something that you could do for your midterm project, but you would have to make sure all your different options are in there and everything else and every use case in there, that kind of thing. Please don't do tic-tac-toe for your midterm, all right? But this is how you would logically think through the game. Start with the basics. All right, I got ones working. I got my spots all working. Now I need to go do a check. Now I need to make sure that we can play the game over again. Do it in phases, all right? That's part of project management when you guys get into your midterm projects. Don't bite off more than you can chew and try to do too much all at once. Add it in sections, add it in pieces. That way, if something doesn't work, well, you just didn't get to that feature, right? As long as the code executes, you're fine. Does that make sense? Because that'll be real important on your midterm projects. All right. So now we have, if the game over, we're going to break out of this while loop, which will print here. If I was equal to 9, we have a cat game, etc. Let's see here. Do you want to play another game? We should probably do this after we check if it's a cat game, right? Something like that. Because it'll print it's a gag game, but then we're going to go do our game checker. Should we do the game checker? We get to the last move of 9. We probably don't need to run the game checker function, right? Does everybody understand why? It breaks. The reason is if you think about the game mechanics, you are never going to get to a spot where you're entering in the last one and you're going to win. Is there an option where that could happen? Or the last move is going to cause you to win in tic-tac-toe? Think about all the moves. Is there ever a case that would happen?
Unless someone's intentionally losing. Now,
Okay, so the answer is yes, right? It could happen. It would be really weird, but it could happen. So because that's possible that it could happen, we don't necessarily want to do an else, right? If we get to the 9th option, we know it's going to be a cats game. Do we know that though? We don't know, right? So instead of doing that, let's close that out and just send it straight to the game checker. And here we're checking for our patterns. And in this case, if it never matches, then it doesn't matter, right? Well, how do we tell them if it's a cats game?
there's no winner.
If there's no winner, right? But if we put that as a else down here, what happens?
That'll happen.
Yeah, that'll happen every time that there's not everyone across, right? So how else could we do that? Well, we don't know what I is up here, right? But you're onto it, right? If we had our L if I equals 9, well, then we know that that's a potentially a cats game, but we still don't know because we just said on the 9th turn, somebody could win. But you are correct. What we need to do is modify our function up here to take in that current number, right? And so if we pass in move count, right? We're gonna do that with a capital C. When we call game checker down here, we need to pass in I. And now we can say elif move count equals 9. Now we can print the cat's game, right? And the reason that will work is why?
It's already gone through this check.
Well, and we've also already checked here whether or not we found X's or O's. So if it was on the last one and they were all straight X's, that's going to hit this one before it hits this move count. And if it ends up being just the 9th move, we say it's cat game. We're going to return what? True or false? Think about how this works down here. We're going to if and test for the last game. So if it's true, we're going to ask for if they want to play another game. Return true, right? The only time we would return a false or nothing is if we didn't find a match case here. So if we run this game. Okay. 1, 4, 2, 5, and 3. Shouldn't ask me for O, right? What happened there? This returned as a true. We should have got this, right? Let's do equals instead. The idea is that it's just going to check if that's a value, right? That could be a non-type value. It could be whatever. It does not necessarily check to see if it's true. So now if we check to see if it's true. Once I typed in gibberish, it went ahead and went to the next option, right? So there's a little more debugging we got to do. I know you guys are out of time. So we would have to continue to try to debug this a little bit. to see why we're getting one more turn after that is entered in there. Essentially, we're setting the move and we're going through, but it's allowing us to redo that turn before we get back through there. All right, but we eventually did get it to say, do you want to play another game? And if we did a Y, game starts over, but what? We forgot to clear the board, right? So we would need a function to go in and clean the board so we can start over. Is that all we need to do? To write a function to remove the board? What can we do?
I was looking at, is it checking if the spot is already filled with something?
What's that?
Is it checking if the spot is already filled with something?
It's not. So you caught that case too, right? You notice how I typed 4 here twice? And it just accepted the move. So we would need to check to see if there's something already in that spot. And not only would we need to check to see if something's in that spot, it would have to be because we can't just see if something's in there because by default, we have a space in there, right? So we would have to check to see if it's an X or an O, not just a space. Or what? Just check to see if it's a space. If it's a space, well, then nobody's been there yet. Don't have to check to see if it's an X or an O. See what I mean by doing these checks? If you do the inverse of what you're thinking, does that make it easier? In this case, yeah, it makes it a lot easier. Now, instead of clearing this board out, what could we do? You just move this inside your while loop so that at the start of your while loop, it immediately goes to 0. Then you're playing your game of 1 through 9. When this all starts back over, it immediately becomes 0. We don't have to write some weird function to wipe everything out. You just put it in the right spot. I put everybody to sleep today, didn't I? All right. So that's dictionaries. Make sure you guys know how to play with dictionaries, structure the data, play with this stuff. A simple hangman game, or in this case, a tic-tac-toe game, isn't so simple, right? There's a lot of components to a tic-tac-toe game. The good news is on your midterm project, if you did something like this, you have 3 weeks to work this out. It's a long time. Cool. All right, we will see everybody on Thursday. You guys do have a quiz this week. That's what we're going to cover on Thursday. We'll do a review of all the questions, and then you guys can take it as you want. What's that? That was rough.
I might need to come make like an appointment with you. I'm still lost when you talk about breaks.
Okay.
I don't get it yet. And quite frankly, after every class, I have a migraine.
I understand. Because it's completely new than anything you've done. And there again, like you just saw, you're not the only one, right? So you guys just have to slow me down and ask me to go over that, which would be a great thing to do Thursday.
And it's hard for me because every other class I'm in, I have to go back and reread and rewatch through everything. And so it's like, I'm not able, my brain can't keep up with the amount of rewatching there is for all these classes. I have like 12, realistically, I would have over 12 hours to take notes and rewatch everything for all my classes. And so it's kind of like
it will come easier as you go through college.
okay.
You will learn little tricks on yourself of how you can memorize stuff, and all of that comes. You guys are in the first class of the first semester.
That was, I was half following, trying to keep.
For the tic-tac-toe or just dictionaries as in,
general.
okay.
Say I got like 75% of it.
We'll review it.
Manage, even if it's wrong, just to keep connected with it.
Uh-huh. We'll rewrite another game on Thursday.
Easy.
That's the whole point, right? Some people come in and they go, I'll just do tic-tac-toe for the midterm. It's not easy, right? You got to think through all the logic.
There's somebody check.
Rock, paper, scissors. Yep.
Okay.
I did like a text-based adventure game that didn't even work.
Yeah, same. It's like, I only had one room that worked, and if you had common sense, then
I
you
think my
would know to check that room last instead of first.
I think my first edition worked. We're like,
All right, for you guys online, that's all I've got. We're just chatting here in class. It sounds like some are lost. So if you guys are lost, we're gonna review some stuff on Thursday. Oops, and I forgot to stop the recording.